Hello friends, this is Priyanka. Today we are going to solve a problem on stability analysis and root locus technique. In this video, we are going to find out the stability for a closed loop transfer function. So let us observe what is the given question. So closed loop transfer function C of s by R of s is equal to 10 divided by s raised to 6 plus 2s raised to 5 plus 2s raised to 4 plus 3s cube plus 5s square plus 6s plus 1. So we have to take the characteristic equation as this denominator, and this is the higher order characteristic equation. So what is the first step to analyze the stability for this equation? So if we observe, we have to take first Routh array. So how to plot the Routh array? For that we have to make the two rows. So for that two rows we have to select the coefficients for this higher order equation. So I have made here one graph, that is first row coefficient. So how to take the first row coefficient? So I have written with the help of black marker. So we have to take the coefficient for the first row, that is this first number. Then we have to skip this second, then we have to select this third, then we have to skip fourth, then we will select here fifth, and then we will select here 7. So one by one we have to write here the coefficients. So I will take here one vertical line. Now what is the order of first number? So first number the order is s raised to 6. So we have to write s raised to 6, s raised to 5, s raised to 4, s raised to 3, s square, s raised to 1, and last one is s raised to 0. So what is the meaning of s raised to 0? And it is nothing but which is equal to 1. Now for this first row coefficient, in the first row we have to plot here in front of s raised to 6, and for the second row coefficient, now remaining coefficients we have to select. That is, I will mark here with the help of red marker, that is the second number, then 4th, and then 6th. So now we will analyze the coefficients. So which are the coefficients? So for this s raised to 6 we will select here coefficient as a 1. So we will write here 1. Then next is 2. Because s raised to 4 is having coefficient 2, then s square is having coefficient 5, and there is number 1. Then next is s raised to 5, that is 2, then 3, then 6. So these are the numbers. So these two rows are getting plotted. So this is the first important step, that we have to write first row coefficient and second row coefficient. So these coefficient for first row and second row we have to select the alternate numbers. Now we will move for the calculation for the numbers in front of s raised to 4. So in third row, how to select the number? So now we will mark here with the help of red marker. We have to take 2 multiplied by 2 minus 3 multiplied by 1. So I will write here 2 multiplied by 2 minus 3 multiplied by 1 divided by, we have to take this number, divided by 2. So if we calculate this, so 4 minus 3, that is 1 divided by 2, and which is equal to 0.5. Now again for this number we have to again make calculation here. Now I will again mark here 2 multiplied by 5. So I will show arrow 2 multiplied by 5, then 6 multiplied by 1 divided by 2. So I will write here 2 multiplied by 5 minus 6 multiplied by 1 divided by 2. So 2 into 5, that is 10 minus 6, 4 divided by 2, that is equal to 2. Then again here is third number. So again I will take 2 multiplied by 1. Then here we will consider 0. So this is important step. Minus 0 multiplied by 1 divided by 2. So I will write here 2 multiplied by 1, 2, I will write 2 in the bracket 1, that is 2 multiplied by 1 minus 0 into 1, that is 0 divided by 2. So 2 divided by 2, that is equal to 1. So these are the numbers in the, we have to write in front of s raised to 4. Now I will rewrite the numbers in in front of the rows of s raised to 5 and s raised to 4. So numbers we have to write 2, 3, 6. So here 2, 3, 6 and then we have to write 0.521. 0.521. Now again we will make calculation. So I will show here. We have to take same manner, we have to make calculation. 0.5 multiplied by 3 minus 2 multiplied by 2. So I will take here 0.5 multiplied by 3 minus 4 divided by. So divided by we have to take 0.5. Now if we calculate this, we will get the answer, that is minus 5. Now we will move for the next. So here we have to take 0.5 multiplied by 6 minus 1 multiplied by 2. So I will take 0.5 multiplied by 6 minus 1 into 2, that is 2 divided by. So divided by we have to take this first number as a 0.5. So what is the answer here? So answer is 2. So in this way, here only two numbers in this row of s raised to 3, that is minus 5 and 2. So again we will write the two rows number and we will make the calculation. So if I write 0.5, then 2, 1 and here minus 5, 2. Now again we have to make calculations. Again I will mark here minus 5 multiplied by 2 minus 2 into 0.5 divided by minus 5. So in the same way we have to make minus 5 into 2 minus 2 into 0.5, that is we have to take 2 into 0.5 divided by divided by minus 5, because here minus 5 is there. So if we calculate this, we will get the answer 11 by 5. Then we will move for the next. So again minus 5 into 1. Now here no number is there, so we will select 0. Then minus 0 into 0.5. So minus 5 into 1. And 0 multiplied by anything, that is 0. So I will write 0 and divided by minus 5. So if we calculate this, we will get the answer, that is 1. So again we will rewrite these two rows, that is minus 5, 2 and 11 by 5 into 1. So I will write here minus 5, 2, 11 by 5 divided and here 1. Again we will make calculation. So here it is easy. We have to take this cross multiplication, that is 11 by 5 multiplied by 2 minus 1 into minus 5, that is we have to take minus 5 divided by, we have to take this number, that is 11 by 5. So when we calculate this, we will get here, that is answer is 47 by 11. So this is the answer. So I will write here 47 by 11 and again here no any number is there, so we will write here as a 0. Now again we will, if we take these two numbers, that is I will take the rows in front of column s square and s, that is 11 by 5, 1 and 47 by 11 and here is 0. So again we will make the multiplication, that is 47 by 11 into 1 minus 11 by 5 into 0, that is 0 divided by 47 by 11. So if I take 47 by 11 divided by 47 by 11, that is nothing but equal to 1. So we will take here as a s raised to 0. So this is the s raised to 0. Here this first step is getting completed, that is we have plotted the Routh array. So this is the first step. Now we will apply the second step, that is Routh Hurwitz criterion to decide the system is stable or not. So what is this criterion? If the values in the first column are positive, then the system is stable. But what is happening if we observe here the negative value appears. So we can say that the system is unstable. So how system is unstable? Now we have to find out the number of changes in sign. So for that I will write here all the values, that is this s raised to 6 up to s raised to 0, and regarding that we will write the values in the first column. So here if I write all the values in the first column, that here is the negative sign. So I will make positive, 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 then here is negative, then again positive, positive, positive. So these are the signs that appears in the first column. Now we have to find out the number of sign changes in this first column. Now if we observe here, sign is getting changed from positive to negative. So this is the first sign change. First sign change. Now again if we observe, here is also sign is changing from negative to positive. That is here the second sign change. So we can say that in this given Routh array, number of sign changes is equal to 2. So when the number of sign changes is equal to 2, that means 2 roots lie in right half plane. So what is the meaning of right half plane? So if we observe, this is the total S plane, vertical line is imaginary axis and horizontal line is real axis. So these two planes, that is if I give here the numbers, this is the first quadrant, second quadrant, third quadrant and fourth quadrant. So this first quadrant and fourth quadrant are in right hand plane and the second quadrant and third quadrant are in left hand plane. So we can say that the number of sign changes is equal to 2 and therefore 2 roots lie in right half plane. So whenever the roots lie in this right half plane, so I will write here RHS and RHS. So whenever the roots lie in right half plane, then the system is unstable. So we have to give answer by Routh Hurwitz criterion. Number of sign changes is equal to 2 and that's why 2 roots lie in right half plane and that's why system is unstable.